Alright guys, on to success criteria B here, which is where we're looking at learning how to identify what like terms are. This little PDF file here is on your OneNote, ready for you to open and have a look at. This one here, I'm pretty much going to talk through this and look really closely at the examples, just so we can point out a couple of important things on the way. So there's a few rules that we've come up with, okay, and this is all that you pretty much need to know about collecting like terms. So the first one is that terms must have the same combination of variables. Okay, now combination is a key word there because in algebra, AB is the same as BA. It's still the same combination. We still have an A component and a B component, and they are multiplied together. So on this first example here, up towards the top, we've got 4B and 5B, same combination of variables, therefore they are like terms. We could collect that together and get 9B or 9 bananas altogether. Second example here looks at 3M and 9MK. Now they both have M's in it, but this second term here has a K component to it, so therefore they are not like terms. Okay, it doesn't have the same combination. Important thing to remember is this little note here, okay, and the pronumeral or the number at the beginning of the term does not need to be the same. So I could have 107B bananas, I might choose a different letter for that one, 107C, okay, and 2C, they are still like terms because all that needs to happen is we've got the same combination of variables. So we can add 107C and 2C together to get 109C. Down here to term, rule 2 rather, okay, the terms must have the same index. Now the index, if you look over on the right hand side, the index is this part up here, okay, that needs to be the same as well. Now if we look at this first example just here, we've got 6HA squared and 2A squared H. Now they sound different, but we've got the same index and the same combination of variables. In this one here, we've got a H and an A squared. In this one, we also have a H and an A squared. So therefore, they are like terms. If we look at this second example though, we've got 5VC and 9V squared C. Okay, so yes, both of them have a V and a C in it, but the V in this one here is V squared. So we go away from the combination of variables because we have something with a different index, so therefore that is not a like term. Down to our third and final one, okay, when adding and subtracting terms, the same rules apply. So this first one here where we've got 2B plus B, we've got the same combination of variables on each of those terms, so we can add them together to get 3B. So that one there, okay, sweet, we can add those together because we've got the same combination of variables. However, on this second one, we've got 4DE, subtract 4D squared. All right, now we've got a DE component in that first one, and we've got just a D squared, so completely different combination of variables. Therefore, we can't actually do anything with those. And if you were looking at writing that simplified, it would actually be exactly as it already is written. Just like this example down the bottom here, okay, we've got 3 carrots plus 5 CD, or 3C plus 5 CD, so we've got a C component, we've got a CD over here. We can't do anything with those, so it's just rewritten as exactly the same way as it already was in order for it to be simplified.